The panda ant is one of those animals that makes you look twice. It is black and white, covered in hair, and moves around on the ground like an ant. But it is not an ant. It is a wasp. Its specific name is Euspinolia militaris and is part of the velvet wasp family. The name panda ant comes from its coloring, which resembles the black and white pattern of a giant panda. The species was described by scientists in 1938 and is native to Chile. It is a small insect reaching about 8 millimeters in length. And the first thing that makes you question the design is that the male and female don't even look like they belong to the same species. The female is wingless. She spends her time moving around on the ground. The male has wings and can fly. This difference between males and females is called sexual dimorphism. In this case, it is particularly obvious because one can fly and the other cannot. The panda ant lives in dry areas of Chile, including the country's central regions. It is associated with Chile's dry plant-covered forests and spends much of its life close to the ground. Unlike real ants, panda ants don't live in colonies. There is no queen surrounded by workers. Each adult lives independently. The female's main challenge is finding food, avoiding predators, finding a mate, and eventually somewhere suitable to lay her eggs. The female doesn't build a nest for her babies. Instead, she looks for the underground nest of another insect, such as a ground nesting bee or wasp. She enters the host's nest and lays her eggs there. When her larva hatches, it feeds on the developing larva of the host. Eventually, the host dies and the panda ant continues developing. This type of lifestyle is called parasitism, or more specifically, a parasitoid lifestyle because the host is eventually killed. It may sound unusual, but this strategy is actually common among wasps. Many parasitoid wasps use other insects as hosts for their young, so the panda ant doesn't need to provide food for its babies. Its offspring get their food from the host insect. That brings us to another feature that makes this tiny animal rather unusual. The female has a sting. The stinger is actually a modified egg-laying structure. Because the female uses it for defense, it can also deliver a painful sting. The stinger is smooth rather than barbed, meaning it isn't designed to remain stuck in the victims after one sting. This is one reason velvet ants are known for the painful stings. You may hear velvet ants described as cow killers. That name is mainly associated with other species of velvet ants, particularly the red velvet. It should not be taken to mean that Euspinolia militaris routinely kills cows. For humans, the important point is simply that this is a venomous insect that should not be handled. Its black and white coloring may also be part of its defense. In nature, strong and noticeable colors can act as warning signals. This is known as aposematic coloration. The message to predators can essentially be, "Don't attack me." So, did nature flop? If we simply look at the animal, it is easy to think so. Why would a wasp look like an ant? Why would the female lose her wings? Why would her babies depend on another insect? And why would such a tiny creature need such a strong defense? But evolution isn't about creating animals that look sensible to us. It is about traits that help organisms survive and reproduce. The female doesn't need to fly in the same way the male does. Her life is largely spent on the ground, searching for host nests. Her sting gives her protection. Her offsprings get food and shelter from other insects' nests. And her coloring may warn predators to stay away. And suddenly, what looked like a collection of strange design choices starts to make more sense. The panda ant isn't a failed ant. It isn't a miniature panda. And it certainly isn't a badly designed animal. It is a highly specialized wasp that has adapted to a very particular way of life. Sometimes, the animals that look the strangest are not examples of nature getting things wrong. They are examples of how different the solutions to survival can be. So perhaps nature didn't flop. Perhaps we just need to look a little bit closer. Which animal should we investigate next? Leave your answer in the comment section. Thanks for watching, and we'll see you in the next video.